long story. Anyway, so what we're going to do now is say, okay, for every x and z, let's say, I'm going to write it like this. I'll give everybody a second to write that down. Okay, now this seemed like a long, complicated statement, but what the gist of this statement is that if you take any number, like I was saying before, if we have, say, 123, and then I said, all right, 123, what is that? That's 1 times 10 squared plus 2 times 10 plus 3, okay? Well, 1 plus 2 plus 3 is 6, which is divisible by 3, so it is in the integers, okay? That tells me that the original number that I was dealing with, that 121, is also divisible by 3, okay? So when searching for prime numbers, this eliminates a lot of possibilities because you can eliminate every number divisible by 3 just by looking at the sum of the integers that represent the digits, okay? And so this will eliminate a lot of different options when looking for prime numbers, when destroying the possibility of prime numbers. So once you hit 3, you get rid of 6. You could have already got rid of 6 because of 2. And then, well, 3 will get rid of 9, 12, 15, 18, 21, going on all like that, because all of those numbers are divisible by 3, hence making those numbers not prime, because remember, prime says that the number is only divisible by 1 in itself, okay? So if it's divisible by 3, it's not prime. Okay. So what we're going to do is we're going to go along this assumption right here, and we're going to try to show this. Okay? So we are going to investigate. So what are we trying to prove? We're trying to show that this number right here, an minus 1, dot, 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 it's a1, a naught, is divisible by 3. Okay? Going along with our assumption. Okay. Another way to write this is a sub n minus 1 10 to the n minus 1 a1 times 10 plus a naught. This is just what we were showing before. This long integer up here can be represented by the tens. multiplied by the digits. All right, now we're going to do a little bit of a trick on this problem. Okay? So, another way I could write this, what am I going to do? I'm going to add 0 to the problem. Okay? So, a lot of zeros. Phrase it that way. Okay, so now what am I doing with this problem right here? So on this very first step, I'm going from here down to here. So what am I adding? I'm adding 0. I'm adding negative a sub n and a positive a sub n. So if I distributed this a sub n within these parentheses right here, what would I end up with? Right, I would end up with a sub n times 10 to the n, which is exactly what we have right here. And then I would end up with a negative a sub n and a positive a sub n. Well, those would cancel each other out. That's the concept of adding 0. So same way for this one right here. You see that negative 1, what is occurring right there? Well, if I distribute a sub n minus 1 inside of this thing, that negative a sub n minus 1 and the positive a sub n minus 1 right here, they'll cancel each other out. Okay? And the negative a sub 1 right here, positive a sub 1 right there, those cancel each other out. Okay, so I added, how many zeros did I add? I added n zeros. Okay? I didn't need to add anything onto this last one. Okay. So, another way to write this, so 10 to the n minus 1 would be a sub n, and then 9, 9, 9 n times plus, you know what, I'm going to leave off the next one, and we'll just write it like this. A1 times 9, okay? Okay, so everybody that's got a 10 minus 1 on it gets converted into 9s, and then what do we have beyond that? We have okay, plus a sub n plus a sub n minus 1 plus dot 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 plus a1 plus a0. Okay, so through all this manipulation, what do we basically get down to? Remember, our if statement for this. What is the if statement? Where you at? Okay. The if statement says that if this sum right here, the one that we have at the end, is divisible by 3, then the entire thing itself is going to be divisible by 3. Okay? And so I said, all right, well, I'm going to make this assumption that this if statement is true. And now I want to show that this statement is actually true. So what I did, you'll notice that I began with a sub n minus 1, that number, okay? And we just want to determine, is this number divisible by 3? Okay. Well, then we started manipulating it. There's nothing wrong with this manipulation. Until we got down all the way, so we're taking that same number that we have, and we're just manipulating it algebraically by adding zeros. That's all we did, okay? And then, but what happened when we did that is that the assumption of the entire statement ended up appearing right here. And then what ended up appearing on all of these guys? 9s, which are divisible by 3. So, we write this like this. Let's isolate this, because it's not a continuation of that statement. We could say, now, a sub n minus 1, dot, 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 a1, a naught, divided by 3, okay? Now, we want to show that this number that we've been manipulating, if we divide it by 3, it is within the integers, okay? Well, after all that manipulation that we did, we got down to this spot right here. And so that comes out to a sub n is 900, well, not 900, dot, 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 9 plus, dot, 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 plus a1 times 9 divided by 3, and then plus, let's take that other one, a sub n minus 1 plus a1 plus a naught divided by 3. Well, this is sum of two integers which are both divisible by 3. So what does that mean? That means this becomes an integer, this is an integer, add any two integers, and you get that is inside.